Okay, so hey everybody, hope you guys are doing absolutely well this morning. I'm Jonathan Lima. I'm CTO at Pagarmi. Actually, I'm leaving today, so so I'm going to San Francisco. But today, I'm here to talk about infrastructure as code. Just so I can know, how many people here actually work with infrastructure as a daily job? Okay, yeah, some people. Great. Just a quick disclaimer before. This is not a definitive guide on how to do whatever I'm going to talk here today. I'm actually going to talk about my experience building the infrastructure at Pagarmi that solved some compliance issues we had. And I'm also going to talk about some gotchas that we got in our way and that nobody actually talks about it on the internet. It's just, hey, those tools are really fun, use it. And then unexpectedly it's not working and you just don't know why and you have to figure it out for yourself. So uh, let's go. So why infrastructure as code? Actually, what is infrastructure as code? Uh, this is a relatively new concept of describing your whole infrastructure as a piece of code, not like classical infrastructure, what you just spin up a bunch of machines and configure the operating system, install packages, all by hand, or be it through some automated scripts. It's not the same. So why infrastructure as code? Basically, I think the main reason to do it is that you get reproducibility. Why this is great? Uh, Say you have some production environment and then you need to create an staging environment. Classically, what you're going to do is just create a clone of infrastructure and like try to recreate exactly the same thing. Maybe you snapshot some images of your instances if you're in the cloud, or clone some hard drives, but it's not actually the same because you have no guarantee that it will work or behave the same. It's a different hardware, different instances, different network, uh, or you might actually get it working right, but you just spend a lot of time that is not necessary. Uh, and this is basically free with infrastructure as code. Free in work, not in price. Second thing you get, it's immutability. Actually, that's not necessarily something that uh, you can just do it with infrastructure as code. You can even not do it with infrastructure as code, but I won't recommend it. And the third thing, the third and fourth thing is actually the same, is introspection. We know a lot about introspection with code. When you have an IDE, IDE basically knows what your code is doing, or some of it. It can provide auto-completion, it can do static analysis on your code. When you write your infrastructure as code, you can do that on it as well. Uh, and for infrastructure, I think the most important thing you can get with it is documentation. Uh, Imagine, I've seen a lot of infrastructures, large infrastructures, that actually had like tons of documentation in paper, and that not necessarily was the exact the same thing that was running, because instance changes, code changes, and not necessarily someone will update the documentation. When you have infrastructure as code, you can write the documentation as the code. And I'm not talking about, oh, well, the code's documentation can have comments on it as well. But as you will be probably versioning it, any changes will be described, and you can just commit and get your infrastructure, basically. Uh, so here, oops. Okay, so here I'm going to talk about our case in Pagarmi, as I said. So basically, just everybody can understand, Pagarmi is a payment method here in Brazil, a card processing company. We deal with some other payment methods as well, but credit card is the main one. And when you're dealing with credit cards, you have some bureaucracy. You have some rules to follow. Because basically, that's people money. It's not your money, and people can get frauded if you're not secure enough. So the case here was basically we needed to become compliant with PCI-DSS, which is a security standard. I'll talk about it later. But we didn't want to touch our whole infrastructure with PCI-DSS rules because it's really cumbersome. It really slows you down, and it doesn't necessarily mean that you're going to be secure. So we actually wanted to create a small infrastructure who can solve this problem. It had to be secure, of course, as we were going to start credit cards on it. And it basically had two applications running to ensure that. So what is PCI-DSS? PCI-DSS stands for Payment Card Industry Data Security Standards. It's basically some compliance rules, a pretty extensive one actually. It covers a lot of topics, like from how your office should be structured, if you handle credit cards on it, not our case, to how your data center may behave. And for example, AWS is PCI DSS compliant, so I can run on AWS. And rules of how people should be trained to develop applications that touch credit card data. So it's a lot of rules. I don't know what is, okay. So basically what we used here in the whole infrastructure, and I'm going to be over it one by one, we had a lot of software here. So we basically had Vault from HashiCorp. You guys will see a lot of things about HashiCorp here. Arch Linux, yeah, don't get mad at me. We used Arch Linux in production, and I'll explain why it makes sense. Nomad, as well from HashiCorp, Terraform, Ansible, Consul, AWS, of course, and Packer. So, how do we build our infrastructure? And why we choose those tools for it? Well, AWS is pretty straightforward, actually, as we can do basically 100% of anything through APIs. It has support for compute, it has support for databases. We're not actually using RDS, the database service, but it has support for it. And we have high availability through multiple regions or multiple zones. In this case, we're just using multiple zones, but we could expand to multiple regions as well. It's just a little bit harder. Then we use Terraform. Terraform is basically the main component of the infrastructure as a code. It's an amazing tool for building immutable infrastructures, as you can just describe everything as code. It's basically a declarative language, which actually kind of compiles to JSON, but it has a better syntax. I can describe my low-level infrastructure with it, and it can handle apply, update, and destroy life cycles. So basically, after I describe my infrastructure, how it should be, it will make sure that everything is as it should. So if anything changes, like you go to the AWS console and change something there, he will notice it. And what? Just a second. Oh, I'm not sure why this is happening. So cool. It's interesting because I can't see my slide here, but well, okay. Well, but that's Terraform. Wasn't not a bunch of useful information there. Really not sure why this is happening. Well, I'm sorry. Anyway, after Terraform, we still needed to build the instances. Terraform actually just creates the infrastructure on AWS. It can create instances, volumes. It can create like the network as you want. But it won't set up the instances, the operating system, and what you need, whatever you need running on it. So we needed a way to create images, at least for the base of the operating system. And for that, we use Packer. Packer is basically, how can I put it? You can create a recipe of an instance. For example, for AWS, you can create an AMI, which is just an image for a new instance. It can also create Docker images, images for virtual machines. It actually works everywhere. And after you describe what you want, you describe how you want it through provisioners. And it can run shell scripts or anything. It has one integration with Ansible, which is pretty straightforward. And then here we got Ansible. After Terraform, actually Packer starts running, he'll create an instance on the AWS and start to run your provisioners, so he can snapshot in the end. And why we choose Ansible? First of all, because Packer had an integration with it, and we're not using Ansible Tower here. We're just using Ansible as a tool to execute some code that we need inside the machine to get it as we want. As it is immutable, it doesn't make sense to use Ansible Tower actually. It's better than a gigantic shell script, as we're using a YAML script, and it can automate a lot of things without actually creating the bash script for it. It's pretty simple. And then, well, Arch Linux. Yeah, we are using Arch Linux. Please, guys, don't try to kill me. Why we are using Arch Linux here? So, what is the main issue with Arch Linux in production? Things can break unexpectedly at any time because it's a bleeding edge distro. But this is not actually a problem if you're not updating your infrastructure on the fly. When I try to update a machine, which is done automatically through scripts, actually a new image will be built with Packer, and I'm sure that it's running on staging before I roll the image for production. So, and I don't ever update the operating system itself on a running instance. If I need to apply some new security patches, for example, just pretend a 0-day came out, we will actually build a new image, test it on staging, and then roll out to production with the new image. The old instance will go down, a new instance will come up, and I'm sure that everything is working. So I just described a bunch of interesting stuff here. It's everything all cool, right? Everything will work. Not exactly. So I think my main point here today is that when you go to Terraform website and they describe and show how to use it, or any other tool actually nowadays, people would just tell you how to use to create a small pet project, say a running WordPress on some instances, and that's all. They are not talking on the big issues that will arise when you get a really big infrastructure, or actually anything larger than the examples they use, and you have to figure it out for yourself. Part of it is because every infrastructure is different, and that's okay. But I really think we should have more patterns, or we could actually talk about some issues that may arise when you're creating something bigger. And here, talking about those tools infrastructure, actually mainly talking about Terraform, we've got some. The first of all is how to deal with dependent cycles. See, Terraform has a concept of a module, but you can create cyclical references on it, and sometimes you kind of need. See, in infrastructure, let's say you have this. See, cyclical references are not good for applications, but for basic infrastructure, say I have an LDAP server, sometimes I need, on Amazon for example, I need a security group to grant access from the LDAP server to all the other servers, and all the other servers should be able to access the LDAP server. And depending on how I do it, either I'll get a big spaghetti code, or I won't be able to do it unless you really learn how you can structure some modules on Terraform, but they don't have actually any examples of that. The second problem also with dependencies is when you're applying or destroying something, and a resource depends on other one. For example, I have a volume on AWS with some data and an instance. This volume is attached to the instance. Depending on how you declare this, if you try to create a new instance, say you change the AMI, it will actually try to destroy the volume. You don't want that. Maybe it's your database. It's not supposed to do that. There are several ways on how to solve it, but they don't describe it as well. And the third, and I think it's the worst one, you can interpolate count. What this means, it's basically, on Terraform, you can like create many resources. For example, I want 5 instances of the same configurations. I can create just one resource and put like count equals 5. But I can't say like, okay, I have 5 IPs here that I allocated, and I want one instance for each IP. Of course, I could just say 5 IPs, 5 instances, associate one with the other one, but that's just cumbersome. But when we started using Terraform, this is not actually just partially true nowadays. They kind of solve it. It doesn't work 100%, but we had to do a patch in Terraform to actually allow this. It wasn't merged on master on the upstream because they wanted to do it differently, but they said our fix actually worked. They just wanted to do it differently at another time. It wasn't their priority. So we are actually using a branch of Terraform. You guys can see it on my GitHub on this branch. But for the infrastructure, it's basically this. There's not a bunch of issues. These tools are not new, so they work. Just have some issues with some large-scale infrastructures. But well, cool. I have a running infrastructure now, and I want to run some applications on top of it. How I do it. And for that, we basically choose the rest of the HashiCorp stack, which is Nomad with Consul. And first of all, you need to have Consul, which basically means I have configuration and service discovery. Those are really different topics, but Consul do them both, so I'll just talk about them as a single thing. So Consul has a concept of key value store, where you can store actually anything. And we choose to store the configuration of our applications on it. So we can just version the configuration. The applications can actually watch for changes. This is native on Consul. You can just call an API on it, and it will fire whenever some setting has changed. And it has service discovery. Of course, it's not a big deal when you have just 2 applications, which was our case, and this infrastructure was meant to never be touched again, just for maintenance. But it just saves a bunch of time having to configure or discover the IPs, handling DNS, all that stuff. And it also gave health checks. Those are actually useful, and they are based on service discovery. So we need service discovery so we could have health checks on it. And we can just fire an alarm whenever a service is down and watch for anything there. Of course, we have some issues here too. What kind of issues? Well, Consul, as all this new generation of tools, is written with Golang. So it's a single binary, simple configuration file. I really love this new philosophy of tools. But it's also a distributed system. So people are not actually used to deal with it, with this, and we have some issues. Basically, the main issue here is when you have an immutable infrastructure, mainly on AWS, you just don't want to handle things like what IP this machine is getting. I don't care. No, it's not relevant. But you need to remember that Consul, as a key value store, it's a database, and it has a state. So you can't just treat it as just a machine that is running Consul, or 3 machines with a cluster of Consul as a distributed server for availability, because it has data in it. And so the first thing we need to do is to treat it like a database and actually give it a different different volume, which will not change if we rotated the instance. For example, to update the AMI. And the second thing is that Consul is based on a protocol called Surf, which HashiCorp created. It's a consensus protocol, and it really depends on the IPs of the machines. So in the beginning, we just created new machines, new instances, and they got a new IP. But if we rotated all the instances at the same time, we never do that actually in production. Otherwise, the console would just go down. But when we were developing, that was really useful, and the cluster would just crash because nobody knew where the other members are now, because the IP is changed. And they could discover it through DNS, and they could set the new DNS, the new IP address on DNS through Terraform, all that automatically. But it just doesn't work like that because it is still expecting the old nodes to be online. So we had to hard code the IP on AWS for those instances. It's not a big deal, but it's not something that you actually expect to do with immutable infrastructure as a code. But we had to do it. And well, disaster recovery is pretty tedious. You actually need to get in every machine that has Consul running and create a JSON file with the IPs of the other nodes on it, so we can recover and pretend everything is okay again. It's not automatic, and you will actually spend some time doing it. So hope for never having to do it. If you have high availability, you probably won't ever need to do it, but it's pretty painful. Well, now we have Consul running, and we need to actually do the deployment of the applications. So, yeah, another black screen is just reading deployment here. I really don't know what's going on here. Well. Oh, nice. Keynote just crashed. Amazing. Apple software. Never buy Apple. Just kidding. Let me open it again here. Yeah. Now we know what is happening. Cool. So we are back on track here. Deployment. Oh, it's here. Start. And so for deployment, you got Nomad. It's actually another HashiCorp tool. And it basically deals with container scheduling. It can actually run some other stuff, like just running some executable on the machine, but we can bundle everything with Docker, and we can just test the same thing that we do in staging and in development, in production as well. So Docker is probably the best option. It integrates with Consul and Vault. I didn't talk about Vault yet. It's the next topic. But it integrates as well with it. It uses Consul Service Discovery actually, and it can automatically just create services in the service discovery for the services you deploy on it with it. So it's pretty neat. And I think the best thing here, it has rolling upgrades with support for canaries, simple canaries, not those complex things like I want to isolate only this customer with the new version. I can't do that, but it can do some canary, instance-based canary. And it can do rolling upgrades with support for health checks. So if your application starts failing during the rolling upgrade, it will just roll back to the previous version, and you will not have a downtime, hopefully. It still have some problems. I will not just go through all of them because they are the same as Consul. Because Nomad is built on top of the same technology. Nomad is built on top of Surf as well. And the only issue we actually had with it was those two. When the Consul cluster crashed, Nomad crashed as well in the same way. and the recovery is actually the same, but for each of them. So not going through it again. Okay, now you can deploy our applications. There are just two of them, containers, pretty straightforward. Everyone talks about this nowadays. But a pretty unresolved topic nowadays, it's secret management. Uh, you guys probably remember the 12-factor application manifesto. That say that, wow, store your secrets on like environment variables, and it's more secure than storing it on a file. Uh, that's kind of true on Heroku, which created the 12-factor application because there was a limitation on it actually. Uh, on a bare instance running, that's not necessarily true because those environment variables, those values, had to come from somewhere. And people tend to this somewhere being just the file system in another place. It will just load these environment variables from the disk somewhere. It's not safe. It's actually the same thing. So we really needed to do some good secret management here because apart from database passwords, we are storing actually the secrets that cryptographic that encrypts the credit cards in our database actually. We're not using an like an HSM here. It's not needed. It's too expensive. And then we found Vault. Vault is one of the newest tools from HashiCorp, and it can be used in some different ways. Well, basically, it's a password vault. You can store secrets on it. But how can you do it? Well, you can start some plain text passwords on it. Pretty straightforward. You just give it the password, and you can ask for it again. It has support for ACL, so you can control who can get each secret. It has a pretty simple API, so your application can actually get the secret directly from it if you want to. That's just a bit too complex for most applications, so you can just leverage Nomad to do it for you. But there's another pretty interesting feature from it. You can actually create ephemeral credentials for your database. Basically, you just give the admin password for it, and whenever you need to access the database, you create some ACLs and roles, and you can say like, okay, this application can access this database, and you actually give a list of a credential for it, and it has to renew this credential from time to time, because Vault itself will revoke the credential. It's pretty cool. But why Vault Secure? It just looks like a fancy key value store which can store some data that you call secrets. They're not actually secrets for now. No. So it does it by encrypting your secrets with a splitted master key. So no one actually has access to the encryption key that cryptograph the keys you stored on it. So you can divide those fragments for a bunch of people you can trust, not individually, but as a whole. So how this works? Basically, we had to create something called the key ceremony. And no, I'm not talking about that. Not talking about setting these ceremonies. I'm actually talking about something that exists for quite some time. Actually, if you think about DNSSEC, it's something that secures the DNS infrastructure, the global infrastructure. They have something really like what we created here. We actually were inspired by what they created. Basically, how it works. The master key is split using an algorithm called Shamir Secret Split. Vault does everything automatically, and then encrypted PGP key from each key holder. And the key is split between several different key holders that you can trust. And only a fraction of them are necessary to rebuild the master key. So when you need to rebuild the master key is whenever you restart this Vault server. So this can be a problem, and that's why what I'm talking here now. key management is a pain in the ass. That's the truth. The truth. Well, you need people here to just restart the server. So your infrastructure is not automatic anymore. But it's the only point in the whole infrastructure that will actually need some more people to make sure everything is running. And if you have high availability, the probability that you ever had to do this is just if you need to upgrade a server, so you have to shut it down, or some catastrophic failure, and then you need to restart the server. Another issue here is to make sure you always have the quorum needed. In our example, we have 6 keys, and we need three of them to restart the server. So always make sure that you have at least the minimum key holders available. So if any catastrophe occurs, you can just recover. I'll just go a bit fast on logging. It's nothing new, it's just interesting what we're doing here. I'm running out of time, so for logging we basically choose the classical stack, elk. It's a pretty neat stack. It's actually a bit of an overkill for infrastructure that has actually just 2 applications, and it isn't supposed to be changing, but it just works. And one of the main issues that we had here, main discussions actually, is whether to use Logstash or not. As we created the applications from scratch, we actually already do structured logging. Our applications already log on JSON, so that's not really a necessity to use Logstash, as I can just write directly on Elasticsearch, be it through my application or through something like the bits that Elastico created. But we also need to get logs from other services like the journal from our systems, system daemons, and this stuff is not structured. Well, it's not structured in a way you can just throw it in Elasticsearch and use it after. So Logstash is actually useful for that. You either need to crunch data, so you have this system journal, it's not a JSON, you need to transform it in a JSON, and you can use it for it. Or in case you have so much logs that Elasticsearch can just ingest them in real time, and you can use Logstash to buffer these logs and make sure you will never lose anything, just because Elasticsearch wasn't able to handle the amount of data in real time. We also have some issues here. The main one, it sounds pretty dumb, but never try to use a T2 instance on AWS. If someone here uses AWS, they probably know what I'm talking about. T2 instances, they are pretty cheap, even for the hardware they have, but they have a thing called CPU credits. And after some time on max CPU, it will actually throttle your CPU, and you'll be like, oh, what the fuck? Why my cluster isn't working? Elasticsearch isn't even responding. It's just painful until you realize that this was the issue, and it sounded pretty dumb. Another strange thing on Elasticsearch is getting right the correct hardware requirements. First, because you don't know at first the amount of logs you're going to ingest, and after that, because there's no much science here. Okay, you can just put a pretty large machine like 8 gigs of RAM for some low traffic, but you never know what you actually need. So you just try to get it right and change for another one until it works. So this was the tools we used. This isn't actually our project. The whole project, and here we have what using these tools we actually created. We separated into some different components. We call them images, network, management, applications, and deployment. And it looks like this. And I'm sure you guys can read it, but it's basically our project infrastructure. But what is the point here? First of all, just a small explanation here. Brastemp, what is Brastemp? Please, it's not that, okay? Brastemp is actually Consul, Vault, and Nomad. So we basically had one server running Consul, and we decided to run Nomad and Consul and Vault in the same server because they use a pretty low amount of resources. But we didn't want to just call the instances Consul because we had Nomad and Vault running on it. So someone just said Brastemp, it's like Consul, then we just use it. Fun fact. And some tips here. I'm getting low time here. The first one is to use multiple Terraform projects. First, we had like just one big Terraform project, and whenever we wanted to just try something out, it took like several minutes because it just goes to AWS API for every resource and try to see if anything changed. And for most time, you won't be just changing everything. You'll be just changing one resource or just one component. And for that, you can create actually multiple Terraform resources, projects, and they can reference each other, but they are threaded separated. So if you accidentally do a destroy operation on it, you just lose a bit of your infrastructure, not everything. So it's safer also. And never ever blindly run Terraform apply. You can get some really messy surprises doing it. Always run Terraform plan beforehand. It will just do a dry run of everything he will try to do in the next operation. And you can actually do this atomically. You can just output what he will try to do. And when you try to apply, you can reference that state, and it will just try to apply exactly what he told he would do. So no surprises here. What's next? Every project tends to just not be complete. So there are a bunch of stuff we're actually planning to do in the future, but we're not sure exactly on what to do. One thing we're thinking about is on writing tests for infrastructure. Puppet, which is another infrastructure management tool, has this concept. You can actually write some Ruby code that can kind of test your infrastructure. So this sounds cool. Automated state management. Basically, the only real issue here is to manage data. For example, how can I automate with Terraform or something? The backups are just handling the volumes for our databases. We're not sure on how to do it, so it's not integrated with the solution that I just presented here. Dynamic disk provisioning is something related. Today we just don't deploy anything with Nomad that is not stateless because we just can deal with the state with Nomad. They may introduce this in the future, but I'm not sure. And another thing is to use CoreOS. So why? I just said Arch Linux was good. So Arch Linux and CoreOS are actually quite equal on some stuff, and we chose Arch Linux actually because it was pretty lightweight and there was nothing installed on it. CoreOS behaves actually like it, so we made a switch to CoreOS as it has some native support for the tools we're using. And this was it. So it was supposed to be just an overview of what we did here and what you guys can do with these tools. This is actually production. This is running right now with those tools. So every transaction, every request actually that we process goes through this infrastructure. So it's pretty solid, although we have some issues with it. And I hope you guys can just take a look after that and see what you guys can do with these tools. Thank you.